regular polygon, right, that's when all sides and all angles are congruent. So this is definitely a regular polygon, an equilateral triangle, and a square would also be a regular polygon. This is all in your books and on page 203, okay? So for that reason, if I were to do something like this, right, if I cover up the 50s down here, like you have no idea, no side markings. If I asked you just like that, just a triangle, and I give you an 80 there, and I asked you, is this a regular polygon? You would have to right away know that it's not. Because the only triangle that would fit the bill is an equilateral triangle, and that's when at each angle is 60. So if you have, or even if I did this, right, if I covered up these two angles and I just gave you that 50 there, you know right away that's not a regular, right? Or if I gave you something that looked like a square, but I told you that this is 89, not regular, right? Right? Because you need a 90 in each corner for that to be the case. And as soon as one of them is a 90, boom, it ceases to be a regular polygon, right? So you just have to be, that's a very important concept that we're going to be talking about again and again, okay? So back to our handout. Maybe I'll just mention that the province gives you this formula sheet here. This is the formula sheet. I know it looks green on my screen, but it's supposed to be yellow. I just have an old screen in front of me. But this is the sum, the interior angle, the exterior angle, the central, and the number of diagonals, right? And n every single time represents the number of sides. Okay, don't let that scare you. I will say this because it's a common error. The interior angle and the sum of all interior angles looks very similar with one difference, right? Interior angle being that you're dividing it by the number of sides, right? That's the difference between the two. So you got to be careful there. And they have it in slightly different order, but ICE, right? I, C, and E, right? Notice that the wording here, I will use an orange highlighter, maybe it'll stick out, but it says regular, 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 right? Those three are the only ones that they only work for regular polygons. The S and the D works for like the sum of all interior angles, and the number of diagonals work for any type of polygon. But these three, ICE, right, and your study sheet, maybe ICE, only works for regular polygons, right? I don't know if you want to put that on there. All right, let's go back to this. And we're testing starting next Tuesday. And then we're done this unit. And then the week after, we'll do the cumulative exam, which will have all three units that we've covered on it, okay? It's going to be focusing a little bit more on vehicle finance, and then second is trig, and then geometry. That's the order of heaviness on that cumulative. And I'll talk a little bit more about that later on. Okay, so we're going to do some practice questions here, and then I'll hand it over to you a little bit to do some work, okay? Calculate the interior, the exterior, and the central angles for the following. Label them on the polygon using the letters I, C, and E, right? Interior angle, central, exterior. So number of sides, that's always what you need to start with. So 1, 2, 3, 4, 5. Not too bad, right? It's a pentagon. You don't need to write the name down ever, but you should know, if I talk about a pentagon, you should know that it's 5 sides. Okay. You don't have it? Okay. There's a package that has like a blue sheet on top. You never had that? Okay. Anybody else? Okay. So pentagon, n is equal to 5. Order doesn't matter. So if you want to do okay, Brandon, I'll mark that down later. Follow along. It's in, I don't know if you have this handout. If not, maybe just write it down on loose leaf. So the formula for I is n minus 2 times 180 divided by n. Okay, that's the formula. So the interior angle would be 5 minus 2, because n represents a number of sides, times 180 over 5, not 3. A lot of folks, they do this in their heads right away, 3, and then they divide it by 3. But that's not true. N is equal to 5. So that ends up being 3 times 180 degrees divided by 5, right? This just translates to that. Let me just focus here. So interior angle, 3 times 180 divided by 5 is 108 degrees. So there's your interior angle calculated. Right, 3 times 180 divided by 5. Just try it quickly. Central angle. The central angle is 360 divided by n. And notice that, right, the central is going to be in the middle. And it's going to connect. You got to pick 2 consecutive points. So this one, or this corner and this corner. It's up to you. And then you just draw your legs like this. Right? 2 consecutive corners going to the center. That's the central angle right there. That's what we're going to find, the measure of that angle. And that's 360 divided by 5 in this case, which is 72 degrees. Okay. E, the exterior angle is also 360 divided by n. And I will write down a property here for you as well. So this is 360 divided by 5, which is also going to be 72 degrees. These two are always going to be the same. Or the other way of calculating the exterior angle, watch this. I find sneaky ways of testing this. Okay, you take 180 degrees and you subtract the interior angle from it. Where is this coming from? Allow me to show you one more time. If I go up, and if you look at any exterior-interior combo, they're always along a straight line and they always add up to 180. Right? It doesn't matter which corner you were to go to. If you go higher up here, there's the interior there, there's the exterior there, and you can see they're along a straight line. So they're supplementary. Okay? Same here. Right? So if you go back down, this is another way to find the exterior angle. So it's 180 minus 108, which is 72 degrees. Right? Same answer. And now let's label it, because I will ask you at some point on a test or even cumulative, I need you to identify it using letters. So central is done. I only want you to identify one of them. And then you go to any interior. How about we pick this one here? This is the interior angle right here. Make an arc there and just put an eye there. And I like to put the exterior next to it, just to show right? So you extend. If you travel along this side, just keep going, right? Just extend that arm, and then the arm and the other side, right? If you make an arc there, that's the exterior angle right there. I will just show you that it doesn't matter where it is. If this is the eye you identified, you can travel along this side if you want, or this side. I'm going to do this, and the exterior angle is right there. So 5 interior angles, 5 exterior angles, 5 central angles, because it's a pentagon. Okay. Can we go? I'm just going to go up here a little bit to exterior angles, and I just want to add a note right here under this. The sum of exterior angles is always, this is study sheet material as well, 360 degrees. It's interesting, right? It doesn't matter how many sides this thing will have. The more sides you have, still every single exterior angle, if you were to go around that shape, would add up to 360 degrees. So it's always 360 no matter what shape. The interior, the sum of interior obviously will be different, right? So it's interesting. Property. Oh, sorry, I was moving it maybe too fast. So under exterior angles, just write down the sum of exterior angles is always 360 degrees. Think about a square, right? 90, 90, 90. Same with the exterior, there would be 90, 90, 90. So 4 times 9 is 360, right? Think of an equilateral triangle. If it's 60, 60, and 60, right? Maybe I will do this. If this is 60, this is 60, and this is 60, provided it's a regular, then you have a 120 here. You have a 120 here. You have a 120 here. So 120, 120, 120, they add up to 360, right? So there's that. Backside. And I asked you to try these. I hope you did. Okay, so backside, question 2. So we count the number of sides. 1, 2, 3, 4, 5, 6. N is equal to 6. This is a hexagon. So the interior angle would be 6 minus 2 times 180 divided by 6. That ends up being 4 times 180 divided by 6. And 4 times 180 divided by 6, you get 120 degrees. Central angle is 360 divided by 6. This is a mental math question right here. So that'd be 60 degrees. The exterior angle is also 360 divided by the number of sides, which is also 60. Or E is 180 minus 120, which is the interior angle, still 60, right? So both ways, there's 2 ways of finding the exterior angle. Right. And then you find the center. Go to any 2 consecutive corners. If you want to go here and here. And then you make an arc between those 2 legs you drew, and that you put a C there. So that'd be 60 degrees in there. You go to any corner of the actual hexagon and you write down, you make an arc and call that I, and then make an extension. Doesn't matter if you go extending it this way or that way, but there's only one exterior angle. So there's your labeling. One more. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 9-sided nonagon, right? How about this? I'm going to throw in sum. Sometimes the province or me, I ask you, like, what's the sum of interior angles of this shape? Sum is n minus 2 times 180. So that would be 9 minus 2 times 180. 7 times 180. That is 1260. So each angle in here, if you add it all up, all of these interior angles, they would add up to 1260. Okay? Interior angle is 9 minus 2 times 180 divided by 9. So it's really 1260, right? It's 1260 because the n minus 2 times 180 is repeating here, so we already know what that is, except for now we're going to divide it by 9. And that is 140 degrees. So provided this is a regular polygon, every single angle in here, interior angle, will be 140, 140, 140, all around, 140 all around. Okay? And then exterior, we will just go 360 divided by 9. We know that it's 40 anyways, just by looking at this, right? You're like, yeah, I need 40 to get a 180. There it is. And the central angle is also 360 divided by 9, which is also 40. And let's label it. Find a center as best you can. 2 consecutive corners. Make an arc. Put a C in there. I'll put the interior angle up here. And I will extend that side like that. Make an arc and call that the exterior angle. We didn't do diagonals in any of these, but I think I'm going to be able to do that later. No, maybe I'll do that here. I see an opening here. So diagonals. I don't know if you remember that formula. I'm looking at that formula sheet here, and it is n times n minus 3 divided by 2. Right? So that would be, in this case, it would be 6 times 6 minus 3 divided by 2. So that's 6 times 3, which is 18 over 2. So there you can draw 9 diagonals in this shape if you wanted to do that. So there's 9 diagonals. For that particular shape. So changes, the bigger the polygon, the more sides I should say, the more diagonals you'll be able to draw. All right, let's go question 4. This one I'll ask you to write down backwards here. And when I mean backwards is you gotta figure out, you gotta use algebra and work backwards to figure out what happened, right? Because they're giving you, first of all, that's important. It's a regular polygon. The interior angle is 135. They want the number of sides. They want n. So this is how we're going to do this. Find the exterior angle. And this is why. I'll show you the formulas one more time before I continue. This is the formula for interior angle. This is the formula for exterior angle. And you can tell right away that this one is going to be a lot easier to work with than this one. So I'm going to find the exterior, then use this to solve. The exterior angle is going to be 180 minus the 135. And that gives me 45 degrees. Use E is equal to 360 over N to continue. Right, so I'm gonna follow up here. We now know E. We found the exterior angle, which is 45. So we're gonna substitute. We're gonna put this guy in here, and we're gonna go 360 degrees over N. And this is where I do that little trick. This is gonna be cross multiplying and dividing. I put a 1 under here. Not really very. It is just important as a placeholder. And then you cross multiply and divide. So you always cross multiply and divide by what's left over. So cross multiply and divide. So N is going to be 360 times 1. It's just like trig, right? These multiply and then divide it by 45. So 360 divided by 45, you do that in your calculator, you should get 8. And this is an octagon. So step 1, find the exterior angle. Step 2, use the exterior angle formula and just cross multiply and divide to get. So this is probably a 2-mark question. So if you want to be prepared for that, I would add something like this to my study sheet. Okay, so 5, I will do this, and then I will ask you to do the same thing with the one that's next to it here. Okay? It says, calculate the value of the specified side. So they want to find this. I will put a title here. You need trig. Right? This is where we mix trig. That's why I do trigonometry before I do geometry. You need trig for this type of question, and I will show you how that is. Determine the perimeter of the polygon. That's next. We'll do A first. So let's find X. This is a regular, by the way, this is a regular shape, right? If this is regular, then this side will be the same as this side. So if this is 13 inches, we know that this is 13 inches as well. So you've got 2 out of the 3 sides. Before you even think it, don't think it. You can't not do Pythagorean theorem here. Don't do it, okay? A lot of students are like, oh yeah, Pythagorean theorem. It's like, no, it's not a right triangle, okay? How can we easily find an angle here? Right? Central angle, did you hear that? This is technically, it's connecting 2 corners. This is the central angle. Right? That's the central angle. So step 1, right? Step 1, find central angle. C is 360 divided by N. 360 divided by, how many sides does this thing have? Start somewhere, go check mark. Please do that. Even if you're off by 1, it throws everything off. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decagon, right? So I'll make a note here on the side, n is equal to 10. So you go divide it by 10. So that's 36 degrees. So we now know that this here is 36 degrees. To use Cosine Law to find x. That's my second step. Because if you think about this, this is an SAS, right? It's an SAS. I think I'll be able to draw this out, but if you think about it, you have 36 in here, which you just calculated. This is 13 inches, and this is 13 inches. This is my unknown. So it's a side angle side. You can only use cosine law there. So I don't know if you remember the formula, but it's x squared is equal to 13 squared plus 13 squared minus 2 times the first side. It just happens to all be the same side, so it's actually easier. And in this particular unit, it's going to end up being like this, right? Most of the time. Cosine of 36. I don't even know if I left you enough room for the other one. Probably not. Now we're going to type all of this into our calculators and take the square root of it. And that is 64. Don't round just yet. Just leave it on your screen, right? Take the square root of that. That's 8.0344. And I'm not rounding. Well, I could, because this would be answering A. So I technically can round to 2 decimals, and that is in inches. So you've answered A here. All of this just to find A. Just to answer A, I should say. Perimeter is going to be sides, right? N times 8.03 inches, right? Because it's, if you found that this is 8.03, well, there's 10 sides on this, so perimeter is number of sides times that. So that'd be 10 times 8.03, and that would be 80.3 inches. So this answer is B on here. Okay. Now try the same thing with question 6, please. Give that a try. Actually, you can do 6, 7, 8, and 9. You know everything you need to know to work all the way question 6 to 9. Okay? I'll pause this here and then I'll go over it as I take up for stuff. Okay, so here we'll do the same thing. It's hard to see, but this is 24.5, right? And that's feet. So we know this is 24.5 as well. I'm going to find that central angle. Maybe I'll do that right in here. 360 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 sides. And 360 divided by 11, 32.73. Not a big deal, right? So that's our central angle that I'm going to use. That is right in here. Degrees, that's this angle here. So it's side, angle, side. That means I need to use cosine law. So it's a good reminder of using cosine law, right? And then you write out your formula. oops, cosine of 3273. Sorry about that. Z is square root of this whole thing. And I'm also thinking I will start to review a little bit of the vehicle finance very soon. It's all of it. So Z is equal to 13.81, and we are in feet. That would be answering A. And for B, we would just go that the perimeter is 11, because that's how many sides we have. 11 sides times 13.81. That's 151.91 feet rounded. If this question had not been split up into A and B, I would want you to use 4 decimals here before calculating that. So if you're at home, at least write down the answers and try it again. Okay. Let's keep going. A regular polygon. So you want to kind of always be mindful. That might come in handy, right? Regular polygon. They give you the exterior angle, which is 40. Calculate the number of sides. Okay. So they want n. So this is a backwards question. Okay. So they already give you the exterior, so no need to find exterior angle. Right? So we can go straight to the formula, which is just that, and then plug in that 40 in here. So it's 40 is equal to 360 over n. Put the 1 there, cross multiply and divide. So n is 360 divided by 40, which is 9 sides, right? And I need you to show me work on a test or anything. I know that you can guess and check, but I need you to show me the work involved there. Okay. Number 8, what does it mean for a polygon to be regular? All angles are congruent. All sides are congruent. Okay. A hexagon has the following interior angle. So here, this one is new, like we haven't done an example like this, but there are things that I've mentioned that should have given you some hints. First of all, this is a hexagon, so that is 6-sided shape. We have a bunch of interior angles, and they're all here. So 1, 2, 3, 2 angles that measure 124, so that's 5 angles in total. Determine the measure of the 6th angle. And here I'm going to just mention a few things. I'm going to write down what I'm doing here. Find, that's step number 1, find the sum of interior angles. We know that exterior angles are always 360, but the interior we don't know, okay? So the sum is going to be 6 minus 2 times 180, not divided by 6, it's just 6 minus 2, that's 4 times 180, and that is 720 degrees. Okay. So that last angle that we're interested in would be 720 minus, we take away all the ones we have, right? And there's two angles that measure 124, so you can just go minus 2 times 124. So you're taking away the 5 angles you're given. And I'll just quickly go ahead and solve that. $111. You're the first group that sees this worksheet. That's why I have to redo everything from scratch. 111 degrees is that last, is the 6th angle. Okay. And I'm gonna ask you a question here. Is this a regular polygon? Would you say this is not regular? None, like there are only 2 angles that are the same, but that's it. So they all have to be the same. And a regular hexagon, we've already done the math, is 120, right? If all angles are 120, because that's what the interior angle of a regular hexagon would be, then that's that. Okay, so what I'm going to ask you to do, we still have 15 minutes. I would consider this lesson done, right? Like polygons. There's another worksheet that I will show you what it looks like. I'm just making sure everybody has this written down. Looks like this. And it's not hand-in, so you don't have to worry about that. But this is a really good worksheet that goes through the whole thing and kind of walks you through what we've already done. Okay, so this should be in that package you've received. It should be somewhere in that package. I don't know if it's right after this handout we just worked through. And the only thing I'm going to say here is question 4. It says, sketch and state the number of diagonals for the following polygon. This is optional, right? Just state the number of diagonals, like calculate this. You know the formula for that determine the number of diagonals. We know that. So just that. Let me just flip through it just in case I see something else. So this also takes you through other, like these ones here, 8 and 9. Sketch a rhombus and label all congruent parts. It's saying all congruent parts, so make sure you do that. Okay, you got to be able to do that with any of the shapes that we've studied. This is a quadrilateral, one of those that we studied a couple of days ago. So that's that. Okay. And then I'm going to go over this tomorrow. So I would consider whatever you don't get done today as homework. I don't assign a whole lot of homework, as you can tell.